everyone, today we're going to do lesson 5.5 where we're going to apply properties of logarithms. There's three properties of logarithms that we're going to use a lot, especially moving into our applications of logarithms that we're going to do later on. The first one is the product property. So first we're going to let b, m, and n be positive numbers such that b is not 1 in these properties. So the product property says that log base b of m plus log base b of n is equal to log base b of m times n. And this is our product property. So an example, if I have log, let's choose base 3, and let's choose a number that has a good bit of factors. Something maybe like, let's do 30. Log base 3 of 30. So that could be equal to log base 3 of 10 plus log base 3 of 3, since 10 times 3 is 30. And remember, log base 3 of 3 is 1, so I could even simplify this even more and say that it is equal to log base 3 of 10 plus 1 if I wanted to. What are some other factors of 30? Let's do 15 and 2. It is also equal to log base 3 of 15 plus log base 3 of 2. What else? Let's see, factors of 30. I can do 3 times 10, I could do, and then I can do, that's 5 times 2, there's all my prime numbers. So I could do 6 times 5, let's do that. I could do log base 3 of 6 plus log base 3 of 5. So you can notice that if I have this product property, I can split this number here into all of its factors, and I can expand the logarithm. I can also go the opposite direction. I could simplify logs. So let me erase all of this. And maybe we can go the other way. Let's say I had, for example, need an O in there, don't I? Let's say log base 7 of 4 plus log base 7 of 8. Well, I could simplify this and say, well, that's just log base 7 of 32. Let's do another example. Let's say I have log base 5 of 10 plus log base 5 of 4. Well, I could simplify that and say that's log base 5 of 40. What if I had log base 8 of x to the 4th plus log base 8 of x to the 11th? Well, that would be log base 8 of x to the 4th times x to the 11th. And when I multiply those two numbers together, I'd get x raised to the 15th. And then in another property, I'm going to show you that this could be simplified even more. So notice that this property can be used to go in either direction, to either expand or condense the logarithm. All right, next we have the quotient property. The quotient property is kind of similar. It says log base b of m minus log base b of n is equal to log base b of m divided by n. Okay, so let's look at some examples. So I might have an example that says log base, let's not do base b, let's do an 8, make that an 8. Log base 8 of 100 minus log base 8 of 5. Well, I could simplify that to be log base 8 of 100 divided by 5, which is 20. Let's do another example. Let's say I had log base 11 of 14 minus log base 11 of 7. Well, I could clean that up to be log base 11 of 2. I could also go the other direction. Let's say I had something like log base 3 of 6. Well, I could clean that up to be, not clean it up, but I can expand it out. Say, well, that's log base 3 of 12 minus log base 3 of 2. Because 12 divided by 2 is 6. I mean, I could do a different combination. What's another quotient that would give me 6? Maybe, let's say 30 divided by 5 is 6, right? 30 divided by 5 is 6. I know this is true. So this is also equal to log base 3 of 30 minus log base 3 of 5, which also means these two things are equal as well. I could come up with other things as well that have a quotient of 6, and I can expand the logarithms. Let's do like a mix. What if I had log base 4 of 10 plus log base 4 of 7 minus log base 4 of 2. And I wanted to clean this up. Well, first I would simplify these two. And since they're being added together, it would be log base 4 of 10 times 7, which is 70, minus log base 4 of 2. And then I would go ahead and simplify these two logs and condense them down into one single log. And since I am subtracting this one, I would take 70 divided by 2, which is 35. So I'd end up with a log base 4 of 35. So there are my two properties that I have of logarithms. I've got the product property, and I've got the quotient property, and some examples. I've got one more, and it is called the power property. The power property says if I have log base b of m raised to the n, that is equal to n times log base b of m. This is the powerful logarithm property. What it's doing is it is allowing me to take this exponent and pull it out front and multiply it by the logarithm. Let's look at a couple examples. This is saying something like log base 2 of 8 to the 7th. And it's saying that is equivalent to 7 times log base 2 of 8. Notice your exponents here is being pulled down and you are multiplying by. Let's do another one. Let's say I had something like log base 3 of 9 to the 4th. Well, I don't know what 9 to the 4th is off the top of my head. I know I could figure it out, but I could also take this 4 and change it into multiplication. By pulling this down, I'd have 4 times log base 3 of 9. Well, I know log base 3 of 9 is just equal to 2, meaning 4 times 2 is just 8. So log base 3 of 9 to the 4th is just 8, which, think about this. If I know, hold on one second. I know 9 to the 4th, I'm trying to get my pen. I know 9 to the 4th is equal to 9 squared times 9 squared, which is 81 times 81. So I figure out 81 times 81, and that's going to give me 6,561. So if I'm trying to evaluate log base 3 of 9 to the 4th, I'm really saying log base 3 of 6,461 equals what? I can change that if I want to into an exponential statement, saying 3 raised to what power equals 6,561. And this number is just too big. I don't know it off the top of my head. But by simplifying and pulling this 4 out front, I changed this logarithm into something that I could evaluate, giving me a 2, and I found 4 times 2 is 8. This means that 3 raised to the 8th power is going to be equal to 6,561, and that log base 3 of 6,561 is 8. And I was able to do this easily by changing this logarithm using the power property. Let's just do one more example. Let me get rid of some of this. So let's just use a variable. Let's say I have log base 17 of m raised to the 8th. So I can pull this 8 out front. It's 8 times log base 17 of m. And that would be all I'd be able to simplify. So I think that you have a good handle on the three properties now: the product, the quotient, and the power. Now what I'd like you to do is I would like you to take a look at this chart. We've got true or false, and I have some logarithmic statements. I want you to tell me if they're true or false. If they are false, I want you to make a correction, just one change or two changes if you have to, that would make the statement true. And I would pause the video to do this and then come back whenever you are ready. Okay, welcome back. So I've gone ahead and I have written out the trues and the falses. So you can check numbers 1 through 9 and you can tell me if you got true or false and adjust as accordingly. If you have any of these wrong, what I would do is I'd pause the video again and revisit the ones you missed and see if you can find your mistake before we go through these. So number 1, log base 5 of 8 minus log base 5 of 6 equals log base 5 of 4/3. So you can see here you are using the quotient property. The 4/3 is just being simplified because 8 divided by 6 does simplify to 4/3. And so this one is true. The next one, log of 3 plus log of 8 equals log of 11. Remember, there is no base explicitly given, so therefore it's a common log, which is base 10. You're welcome to write these in if you need to. And this is false because we're using that product property. If I have log base 10 of 3 plus log base 10 of 8, I would multiply the 3 times 8 to get 24. So my correction, that would be my correction. I would change that 11 to a 24. Not the only one you could do, but that's probably the easiest one. Number 3, you've got 5 times log base 4 of 2 equals 10. Well, let's see how they might get that. When I look at this, I see log base 4 of 2 can be simplified, and it is just a half. And that's because 4 raised to the 1/2 equals 2. So 5 times a half is not equal to 10. It is equal to 5 halves. And so that's how I would change this. I would say 5 times log base 4 of 2 is equal to 5 halves. Or you could change that 5 if you wanted to a 20. You could have your correction look like this. 20 times log base 4 of 2 equals 10. And that would make that a true statement. The next one, I have negative 3 times log of 2 equals 1/8. And that is true. Why do I have false here? I've got true, false, false. This is true. If I move this negative 3 up here, that becomes log base 10 of 2 to the negative 3rd, which is log base 10 of 2 to the negative 3rd becomes 1/2 cubed. And 2 cubed is, oh no, it is false. Just kidding. It's log of 1/8. Not 1/8. You're missing the log base 10 in there. That's why it's false. So I could just simply write log base 10 in front of this 1/8, and that would be true. So no, that is false. So I could give myself some check X, 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 just so we could see that. So far, we got 1 true, 3 falses. All right, number 5, I've got log base 7 of 4 plus log base 7 of 3 equals log base 7 of 12. That is true by the product property. 4 times 3 is 12, so I am all set on that one. The next one, log base 4 of 20 minus log base 4 of 5 equals 1. And that is also true. Whenever I simplify the left-hand side, I have log base 4 of 4 when I divide that 20 divided by 5, and log base 4 of 4 is 1. The next one, log base 7 of 10 minus log base 3 of 5 equals log base 21 of 2. That one looks good. The issue is these bases. Since the bases aren't the same, I can't use that quotient property. And to correct it, just change those bases to all the same base. You might change them all to 7 or 3 or 21. You can change them to anything you wanted, and this would be a true statement. The next one, log base 9 of 56 minus log base 9 of 7 plus log base 9 of 2 equals a 16, and that is true. When I go through and use my properties, first I would divide the 56 divided by 7 to get an 8. Then I would take the 8 and multiply that by 2 to get this 16 here. And notice the bases are all 9, so everything is good there. The last one, natural log of 12 plus the natural log of 6 equals natural log of 18. So notice using that property, this 12 and the 6, I should be multiplying those, not adding them. So when I take the 12 times the 6, I should get a 72, and that would be my correction there. All right, so hopefully you feel good noticing the properties and being able to use all three. Now that we know the properties, let's start to condense a couple logarithms. So here we have multiple logarithms, and I want to condense to a single one. So the first one, I've got log of 9 plus 3 log of 2 minus log of 3. The first thing I want to do is I want to pull up any of these back to the exponents. So this would give me log base 10 of 9 plus log base 10 of 2 cubed. 2 cubed is 8 minus log base 10 of 3. Next, what I'm going to do is I'm just going to go left to right. So I'm going to condense log of 9 plus log of 8. Using the product property, I'll multiply the 9 and the 8 to get 72. And now my last step, I will condense these using the quotient property, giving me log of 72 divided by 3. And when I take 72 divided by the 3, I'm going to get a 24. So I'll get log base 10 of 24. So I've condensed this expression of 3 logarithms being added and subtracted into a single logarithm. All right, let's take a look at our next example. I've got log base 2 of x plus log base 2 of y to the 5th minus 6 log base 2 of x. So again, first I'm going to take anything being multiplied and I'm going to pull it up into my exponent. So I'll have log base 2 of x plus log base 2 of y to the 5th minus log base 2 of x to the 6th. Next, I'm going to go left to right. If I were to condense these two logarithms, I'd be multiplying the x and the y to the 5th. Well, that would just give me log base 2 of x y to the 5th when I multiply them, minus log base 2 of x to the 6th. And next, since I'm subtracting these, I'm going to end up dividing x y to the 5th divided by an x to the 6th. And that would simplify to log base 2 of y to the 5th over x to the 5th. I could leave my answer just like this if I wanted to, but since I notice that both the x and the y are raised to the 5th power, I could go a step further and say this is log base 2 of y over x, both raised to the 5th. And if I wanted to simplify even more, I could pull that 5 out front. So I've got 3 different levels of simplification here that I could use. That should be next. Now what we're going to do is we're going to practice expanding the logarithm expression. So I have log base 10 of 3 times x to the 4th. So I'm looking for these multiplications and divisions that I can undo. I have no division to undo here, so I'll skip to multiplication. And I can change this to log base 10 of 3 plus log base 10 of x to the 4th. And then the last thing I need to do is I need to move any of these exponents out to the front using that power property. So I have log base 10 of 3 plus 4 times log base 10 of x. And now I've expanded the logarithm. Let's take a look at the next one. I've got log base 6 of 5x cubed all over y. And notice that 5 is also being cubed. So first what I think I'll undo is the quotient. So when I do this, I'll have log base 6 of 5x cubed minus log base 6 of y. Next what I'm going to do is I'm going to pull this 3 out front. So I'll have 3 times log base 6 of 5x minus log base 6 of y. And next what I need to do is I need to undo this multiplication here. So now I've got 3 times, now this log base 6 of 5x, I'm getting ready to split it to 2 logs. So I need to make sure I use parentheses to make sure that 3 is being given to both logarithms. And then if I want in my last step, I can go ahead and distribute that 3. So I'll have 3 times log base 6 of 5 plus 3 times log base 6 of x minus log base 6 of y. And notice it's really important that both these logarithms have that 3, since it's both the 5 and the x being cubed in my original. So that is some practice both expanding and condensing logarithms. All right, last example. I've been given these two logarithms some approximations that log base 4 of 3 is about 0.792 and log base 4 of 7 is about 1.404. What I want to do is I want to use those approximations to evaluate the 3 logarithms below. I've got log base 4 of 3/7, log base 4 of 21, and log base 4 of 49. So on the first one, if I were to use my quotient property to expand it, I would have log base 4 of 3 minus log base 4 of 7. And since I have these approximations, I know log base 4 of 3 is the 0.792, and log base 4 of 7 is 1.404. So when I subtract these two numbers, I get negative 0.648. So log base 4 of 3/7 is, I should say, approximately negative 0.648 since I'm using approximations. Now the next one, I've got log base 4 of 21. So I know that 21 is equal to 3 times 7. So I can rewrite this logarithm as log base 4 of 3 plus log base 4 of 7. So now when I change these into my approximations, I got 0.792. I'm adding 1.404. And when I add those two numbers together, I get 2.196 approximately. And now the last one, I have log base 4 of 49. So I notice first off that 49 is 7 squared. And then I can move this 2 out front. So this just becomes 2 times log base 4 of 7, which is approximately 1.404. And when I take 2 times 1.404, I get 2.808. So log base 4 of 49 is 2.808. That concludes our lesson for properties of logarithms. They're going to be really important as we solve logarithmic and exponential equations in the next section and take a look at some applications in lesson 5.7. So go ahead and work on your problem set before we move on to the next lesson.